right, so this next part says to factor by grouping. We're still continuing with using the distributive property, but we're going to look at grouping them together. And when I'm looking at this, the first thing that I'm thinking of is, okay, there's nothing that all of these have in common. But if I look at these two terms, I can see they're both divisible by 2 and they're both divisible by u. And I can see that both of these are divisible by 5. So I can look at this and I'm going to factor out. I'm just going to go ahead and write the prime factorization. This is 2 times u times v. The prime factorization of this one would be 2 times 3 times u. Prime factorization of this is 5 times v, and the prime factorization of this is 3 times 5. Okay, so when I look at that, if I factor out the 2u from here and here, bring that to the outside, I'm left with v plus, what am I left with here? 3. Okay, that's going to put me back here. Okay, what do these both have in common? Well, they both have a 5, so I'm going to factor out that 5, and then I'm left with a positive v and a positive 3. So that gets me back to here. But look what I have here. Think back to when we were foiling, when we had a binomial times a binomial. I have 2u times v plus 3, and I have 5 times v plus 3. So what that allows me to do is group that 2u and that 5 together, and then just have the v plus 3 once. And you might be thinking, okay, why? It was twice. Where did it go the second time? Well, in the way this problem's set up, it takes care of writing it twice, because this tells me, if you think back to foiling again, that I take the 2u and I multiply it by v plus 3. Then I move to the 5 and I multiply it by the v plus 3. So there's no need to write it twice, because the foiling method takes care of that in getting it, both terms being distributed to this v plus 3. So my factored form then is 2u plus 5 times v plus 3. Take a second, pause the video, and try this problem here. Okay, so I looked at this, I saw that both of these terms were divisible by t, so I pulled that t out, and that left me with w plus 10. I looked here and said, okay, both of these are divisible by negative 2. So if I pull out a negative 2, I'm left with w. Negative 20 divided by negative 2 leaves me with a positive 10, and voila, I have the same thing. So I rewrote it as t minus 2 times w plus 10. All right, and now it's not always so cut and dry where we end up with the same thing in parentheses like we did up here. Sometimes we have to manipulate the problem a little bit, and that's what this is. So I'm going to go ahead and group these. I'm going to look for the GCF here. Looks like the GCF would be negative 3m. Right? Both of these are divisible by negative 3, or maybe you want to say, no, they're not divisible by negative 3. They're both divisible by a positive 3. Doesn't really matter which way we look at it. I can get the same thing. If I divided this by negative 3, I'm going to be left with a negative 7, right? That m's already out there. If I divide this by negative 3, that leaves me with just a positive p, because I already took out that negative 3m. Okay, looking here, what are they both divisible by? They are both divisible by, I could do a positive 4 or a negative 4. It doesn't matter. If I pull that 4 out, I'm left with p. Negative 28 divided by 4 leaves me with a negative 7. So even though these are written in a different order, it's still the same thing. A negative 7, positive p, positive p. So I can rewrite it as negative 3m plus 4 times p minus 7. Now, what I did here was the prime factorization in my mind. I looked at this to see what, to find the greatest common factor, and I could see that both of these were divisible by 3. If I would have factored out just a positive 3 here, I'd like to look back at that. If I just was to factor out a positive 3m, then I would have been left with 7 and then negative p. And over here, I would have had, I factored out a 4, so I would have had a p minus 7. So these would have been different terms. See, this is a negative, this is a positive, this is a positive, this is a negative. So the reason that I do the negative, pull the negative out, is because then that makes these alike. A negative times a negative makes that a positive 21. A negative times a positive makes that a negative 3mp. All right, so I would again encourage you to pause the video and try the next one. I've already kind of grouped them together for you. So go ahead and pause the video and give it a try. Okay, so here is my final answer. I factored out a negative 3x squared. You may have just factored out a positive 3x squared and then realized that these didn't match in the end and went back and changed the sign. That's fine. So then in their factored form, I get negative 3x squared plus 4 times x minus 11. And that's a wrap for today. Hopefully this made sense. If you have any questions, make sure to reach out to me and let me know.